Hi, I'm so excited. This is our last video for our Math 3 EOC review. I've made videos a while back, like 3 years ago, but I've updated them since then, so I've been itching to get these remade. So I'm just happy to be almost done. Um, if you're taking Math 3 in North Carolina, there's a really high chance, high probability, since we're talking about statistics, that you may have not covered statistics because it's a very, very small chunk of the curriculum, and there's a lot of stuff that you got to learn, a lot of stuff crammed into one semester. And so this oftentimes gets cut. I teach AP statistics. I find statistics very useful, but the way that North Carolina decides to put statistics in there, and if you're part of the North Carolina people making the curriculum, you need to listen to me right now. Figure out how to get statistics better done or take it out of here, because it's the way that you have it in here crammed for just a couple of days doesn't do it any justice. Okay. Math doesn't work like that. You need to have continuity. So that's my 2 cents. Anyway, I got a few questions to go. Here are the standards. Here's just some things you might need to know. Talking about samples versus population. A population is a small, or a sample is a small subset of a larger population. There are different ways to obtain data. You can do experiments where you're comparing and doing random assignment to try to show cause and effect. But you have to have ethical things to do in experiments. Otherwise, you do something like an observational study where you're just looking at data. You may just decide to do a random sample, like a systematic random sample or a simple random sample. Or you might run a simulation using computer models or random number generators to simulate data that you can't easily collect. You'll also be able to do some margin of error calculations. There's tons of margin of error formulas here, but here's the basic one that you'll probably need to know on this exam based off of my past experience with seeing released questions. You need to basically take your standard deviation, should be provided that in a sample, divide by the square root of the sample size and multiply by 2. And you can get a confidence interval that way too. And that's for a 95% confidence interval, which you probably have no idea what I'm talking about, because how are you going to learn that in 2 days? I mean, this is a whole chapter in AP statistics, but I digress. So let's go over some problems here. Question number 1. I hope this is common sense. Read through it. A reporter wants to know the percentage of voters in the state who support building a new highway. What is the reporter's population? And population is who you're trying to sample from. So population is not the sample itself, but who you're sampling from. And who are we sampling from? Well, we're talking about voters. So the number of people that live in the state is not your population, because there are kids that can't vote. So no bueno. B, the people who were interviewed in the state. That's your sample, not your population. All voters over 25 years old in the state. Why does age have anything to do with it? It says voters, percentage of voters. Voters in most states are 18, so that's no good. So the answer is all eligible voters in the state. That's your population. Next. Number 2, a student wants to determine the most liked professor at her college. Maybe it's me. Which type of study would be the most practical to obtain this information? A simulation? Do we want to run tests and models to do this? That seems extra. I think I'm going to pass on that one. An experiment? Do we want to put some people in one class, another, and see how? Why? No. We don't want to do that, because first of all, that affects people's learning schedules. No, we're not going to do that. So we're kind of down to a survey or an observational study, and it's best probably just to ask in this case. I mean, why look at data, when it could be all convoluted? We can just do a survey, sample them randomly, see what they say. Seems to make the most sense. Next, number 3, what method should Josh use to determine if why has it got to be Josh? Determine a new treatment for baldness is effective. Random sampling, experiment, observational study, or telephone survey. Hello, is your baldness treatment working? I don't think a telephone survey is going to be very practical. Observational study, maybe we could do that. But I think we're trying to show cause and effect, right? Cause and effect is best left to the experiment. Can we give them a treatment and compare with another treatment? So we want to compare treatments. And I think an experiment is a very, very good thing to use for that model. So experiment is going to be my vote on that one. Next. Guys, you don't know how happy I am to be almost done with these videos. I've spent a lot of time with these videos. Hopefully they're helpful for you. If not, then I just wasted a lot of time. All right, this question. A high school randomly selected 30 of the 500 seniors at the school to take a sample college entrance exam. The mean grade point average of the seniors selected was 2.15. And the standard deviation was 0.62. So we represent mean with this symbol and standard deviation usually with S or S of X for that symbol here. The question for 4 says, what is the margin of error for the mean grade point average, assuming it's a 95% confidence level, which it didn't say, but that's what we're going to use. So here is how you calculate that. You take the number 2, you multiply it by the standard deviation, and you divide it by the sample size. And you'll have to know that formula, unfortunately. I don't think they give that to you on the exam anymore. So 2 times, that's a times. So 2 times the standard deviation is 0.62 and divide it by the square root of, what is my sample size? We got a high school randomly selected 30 of the 500 seniors. Ooh, which one is the sample? Yes, that's 30. This is going to be your population. We're not sampling the entire population. We're sampling these 30 from the 500. So we'll throw in 30. At that point, you're going to throw that into some sort of calculator that can do a square root and division and times and see what you get. Pause the video if necessary. All right, I have it ready to calculate. Drum roll, please. 0.226. That was kind of lame. All right, so my margin of error is 0.226 points on my grade point average. You might be asking yourself, what does margin of error mean? It means how far you can be off by and have some reasonable confidence that you're ballparking the true mean grade point average of these seniors. So my margin of error is going to be, you can go right, like a plus or minus if you want. It could be above or below, but that's how far off you can be. You don't need the plus or minus, but 0.226 is your margin of error. Now, the most important fundamental question of statistics. I love statistics. If we increase the sample size, what's going to happen to your margin of error? Just think for a minute. If you sampled everybody, is there any error? No, because you have the exact average. There is no error. So the more you sample, the smaller your margin of error gets, okay? Here's a little graphic. The higher the sample size, as n increases, the margin of error decreases. But I can back that up with numbers. All right, let's plug in a number for 30 that's bigger than 30. Let's do 2 times 0.62 times, I don't know. Let's sample 50. When you divide by a bigger number, you get a smaller number. And so the more that number gets increased, of course, you don't want to sample too many because then you get a margin of error of nothing, but the smaller your margin of error gets. So the answer to this question is the margin of error decreases when the sample size increases. Guys, I wasted a lot of time doing these videos. I hope they help you. Maybe the mean percent proficient on the EOC for North Carolina will increase because of these videos. I doubt it. Anyway, have a great life, if I never see you again, day. Most importantly, y'all, you're going to need to do something very important going into your EOC. Okay? You ready for this? Study. Signing off. Peace out. Love you. Bye.